Hey everybody, this is Brad Dyke reaching out to you and just wanted to touch base. I was talking to one of my professional affiliates and he brought up to my attention something that was pretty important. And I thought, you know what, I should touch base on this before the 2024 ends because at the beginning of 2024 I did a lot of pre-design work with what you see up there in the upper part of that rack, which if you look over there, the top, the middle, and just below the line where you see the pink papers, they are basically a reduced format cluster Proxmox footprint and a Raspberry Pi distributed load cluster footprint. And it has in the middle there, those blue lights you see, those are a series of hard drives which are in the intermittent mix of that system. So let's take a quick closer look. So I did a pretty extensive video of using these series Optiplex series 7040 arrays. These are basically workstations, thin stations to be exact. They're small form factor. They're i7s. They have 36 gigs of RAM in them. They're 8 core, and they have 1 terabyte of drive SSD wise inside them. Plus they're booting off an NVMe boot drive to boot. So it's got the 250 gig capacity NVMe, and it's got the 1 terabyte drive SSD wise for capacity for the Proxmox cluster environment. And of course it also has the distributed storage capacity of NFS for the common cluster storage resource pool. Now below that we also have what I call junk data drives, and these drives here are physically inside. If you look in there, you'll see them. These are iStock 5-bay drive disk arrays, and they're USB 3.0, very functional, very powerful, and can do quite a bit. And there's 15, 15, and 15. So I've got right here the technical capacity of doing what is called a RAID 50. And what a RAID 50 is I can take 5 drives, 5 drives, 5 drives, make them into 3 separate entity drives. In other words, 15 terabyte to 15 terabyte, 15 terabyte. And then I can go up and I can RAID 5 those sets into a RAID 5 stripe parity. Now what does that represent? Well, let me explain what that represents. What it represents basically is that how can I, with my little tiny footprint, and I don't have much power there, right? You know, I've got a 10 gig switch down there for high bandwidth, and I got a 1 gigabit switch on the front end for the nodes to communicate. But you know, it's not that much hardware. I mean, it's a few Raspberry Pis. It's 15 hard disks to sit up in some iStock platforms, and 7 arrays. Now, with the 7 array footprint, I can actually do quite a bit with it. You see, that Proxmox environment there can represent something a lot more sophisticated than just simply my home lab. It could represent 3 different regions. Now, for enterprise architects, what I mean by that is you can create mini cloud providers, basically. So I use my Raspberry Pis to create what's called cloud services, and then I use the disk storage capacity as regional pools. In other words, the first 5 disks represent disk capacity in data center Alpha, and the next 5 disks will represent data center Charlie, and the other one will represent data center Zulu. Now those are 3 different locations. In AWS mindset, we would call that a distributed service in a single region, or if you use 2 Raspberry Pis in failover states, they would represent 3 separate geographical regions that have multiple service provider nodes inside that. And so basically what that means is for the first 5 disks you see there and 2 Raspberry Pis, that would represent 2 data centers in the East Coast. Okay? And if one went down, it didn't matter because the second one was still there. The East Coast is still operational. Your business continuity model is working. Now then you go and do another 2 Raspberry Pis and you create the West Coast. And then the last 5 disks you associate with the last 2 Raspberry Pis, and you put that out in Australia by putting on a slower network switch to introduce latency to the equation. So you've got yourself some pairing going on, and you've got distribution. So what you do now is you can say, hey, all 3 of you sets of Raspberry Pis please give me one pool of disk storage between your 15 hard drives on 3 different site locations. And voila, I have a multi-cloud environment. Now, what does the Proxmox have to do with this? Well, you can do it two ways. One, you can have what's called Proxmox Alpha and Proxmox Bravo, two different sets of Proxmox clusters. The first one, let's say it's going to be the first three, he'll represent the East Coast. And I can do about 15 virtual machines there between those 3 nodes, or I can do about 45 containers, or a mix. And then I take the remaining 4 nodes that I have up there on the top, and I'll make them the West Coast. And that would be my failover environment. So what I'd have to do is I use my little Raspberry Pis that are running the cloud service provider function and a binds service. That's DNS, by the way, for those who don't know what that is. The binds services will provide DNS services that allow you to have what's called a failover state. Now what that means basically is if you have an agnostic operating system, let's say like Rocky or Alpine or Ubuntu or Debian or Red Hat, the key secret is it's agnostic of cloud providers. It will run in any setup you have, any virtual machine or containerization that you've got. And they can be in any of those 2 sets of Proxmox back and forth. So you can set up node Alpha and Bravo and Charlie on your Proxmox A cluster, and then you can set up node Zulu, X-Ray, and Oliver, right, on the 4 node cluster called Proxmox B. And so you've got 3 nodes in the East Coast and 4 nodes in the West Coast. They are all part of the same cluster, but they're built in such a way so that they'll service each other if something happens on either side of the fence. Now, I won't get into the latency effects of that. That's kind of a complicated thing. Don't go too far on that strategy just yet, because you got to learn the basics first. Always learn the basics and get good with the basics, then progress into more advanced fields associated to them. So what you do basically here is you don't want to create necessarily a hot-cold cluster of the East and the West Coast, but you want to create a balancing between the 2 of them. How do you do that? Well, it's easy. You see those Raspberry Pis on the bottom that control all that disk storage? Well, that disk storage is NFS storage. And that NFS storage is made available to both sets of clusters. 3 regions of data pools representing 1 data source for storage, going to all 7, or let's say 8 nodes, 4 in the East and 4 in the West. 4 running on Proxmox Alpha and 4 running on Proxmox Bravo. And they basically will sequentially exchange their pecking order in their cluster. Now, what do I mean by that? Well, clusters can be basically set up in a couple of different formats, but most of them are usually referred to as what we call the old school of round robin. In other words, whoever's available first, come around and you're going to get the next workload, the next user who connects. The second model is sequential value and decentralized sequential model. Those are the 2 other options which you have. Decentralized sequential model means I want you to do a sequential model that I dictate. Sequential cluster distribution is simply your node 1 through 8, 1 through 8, 1 through 8. Everybody is equally distributed sequentially across the cluster state. Now, there's a lot of verbiage in that. We don't want to get into that too much until, again, you get the basics. So what I've got up there in that tiny little section up in my home lab is an actual multi-cloud environment that's providing resources on the bottom, the storage in the middle, and representing 3 physical locations on the Earth, which is what you need for business continuity. And up there, I have my clusters of resources that are running nodes that are using that storage that are handled and controlled by those service providers on the Raspberry Pis. Now, here's something that's important to understand. So when I say understand the nature of a primal basic model, these exponentially represent the environment of the 100, the 10, and the 1 gig environments, okay? So in that case, what we have down here is we have a primary 1 gigabit switch. We have a delayed switch here, and we have the 10 gigabit infrastructure here. So this is my slowest right here. This is my common 1 gig environment, and this is my 10 gig environment, which would represent 100 megabit or 100 gig infrastructure for bandwidth, like storage and so on. And of course, this represents the 10 gig infrastructures that you see internally within like AWS or Google. And then of course, you've got your outbounds, generalized connectivity, which the users come through. So it's a mathematical equation is what it is. You take the nature of your Raspberry Pis down here, okay? Here is the east and here's the west, okay? In the back are 2 more Raspberry Pis, and each of them 2 to this one, 2 to this one, and 2 in the back to this one. They all communicate, and they provide NFS storage through the heads here. These guys are communicating up here, saying, hey, can I have some NFS storage? He says, sure, here you go. Here's your pool. There are the resources. Up here we have our distributions. Now, mathematically, you can break that down in such a way so it will equate to what a real data center in a real region, which has multiple data centers in it, within a real geographical location, depending on its region. So this is technically Cluster 101 for business continuity on hybrid models using multiple cloud providers. What does that mean? How do you get there? I don't understand. It's complicated. Actually, it's not. Here's the secret sauce to it. The easiest way to do this is just to bring up your Raspberry Pi, just one of a cluster node. Just create a cluster with 1 node in it. That's usually the controller node. And that guy's going to sit out there and he's going to get his disk storage. Okay? Then what you do is you set up your 2 Proxmox clusters, right? You got, let's say 3 and 3. That's good. That's fair. And on each of them, you'll want to create 1 node for, I don't know, PHP, right? For a console. So you've got up there, you want to create a console for your new CRM that your employee base is going to use. So what you do is you have just a single node down there in the Raspberry Pi representing just 1 cloud provider who's got some disk space capacity. And then up on the top, those 2 Proxmox, Alpha and Bravo, will host on Alpha one of your nodes called Node 1 for your PHP cluster. And then you've got Node 2, which will also be part of your PHP cluster. You're going to use what we call an application load balancer, not a network load balancer. They're 2 different things. You can't really put a network load balancer behind a firewall, but you can with an application load balancer. So it's an important detail. You'll have to research that on the sideline. I might cover it in another discussion. But your 2 Proxmoxes are basically together in a very, I hate to say it for the 3rd time, basically a simple cluster. That's it. You've done it. So you've got 1 region with 1 5 set of disks linked to 2 nodes in the cluster. Now, what do you do after that? Well, what you do next is you want to create down here the other 2 regions. That would be 1 Pi per each region, right? So 3 Raspberry Pis, one representing region A, B, and C, right? And that could be the East Coast, the West Coast, and Europe. It could be Brazil, Japan, Australia. It doesn't matter. The point is they represent basically large areas of space because within each region, there's more than a single database. That's why they're regions. So we're not going to go there yet. Stick with me and stay focused. So we still have a fully working 2-node Proxmox PHP cluster up at the top, load balance, ready to go, and it could access 1 pool of disk storage for its resources. Okay? Now what we're going to do is we're going to mirror the Raspberry Pi 1 region center with the Raspberry Pi 2 region center, or in this case, Bravo. And they're going to merge their disk capacities, maintaining the integrity of the cluster that's above. You can do that. Or what you can do is you say, now that you've learned enough about the basics of establishing cluster nodes, you can take it back completely down, take your nodes offline on the Proxmox, leave the Proxmox clusters up and running, and what you would do is you would bring 1 Raspberry Pi up per each region, okay? So that's 3 Raspberry Pis, each accessing their own disk capacity, and it's 15 disks together. You basically bring those 15 disks into 3 sets of RAID 5, and you bring them together, and then you're going to combine those 3 guys to create one storage pool, which to the end user is 0. This is called RAID 50. You RAID 5 to RAID 0, or RAID 50, or you've heard the term RAID 60. That's another example of that. Basically, that's 2 hard drives in parity versus 1. It's a little bit more redundancy. It is wasteful in hard drive, though. But up there, as you can see, if we're doing a RAID 50 configuration, those 3 Raspberry Pis have their disk pools built, and then they offer it all together in a synchronization between the 3 of them to maintain a single source that NFS-wise can be connected to the Proxmox. So what happens there next is the Proxmox gets access to 3 terabytes of data, as an example. They don't know that that actually represents a lot more disk than what they see. They just see 3 terabytes. Now, granted, that that's 15, 15, 15. So really, that's 30 terabytes of capacity in the background. That's overhead. That's not your expense. That's the cloud provider's expense. You can ignore that for now. But you've got an actual entity created. Now you've got 3 different cloud providers out there, and they are giving resources out. And the Proxmox represents your home for virtualization and containerization. Now, could you combine them into the Raspberry Pis? Yes, you can. Why didn't I do that here? Well, the reason why is because I got to tell you that when you become dependent on the nature of a cloud provider's services that are proprietary to the provider only, you pigeonholed yourself into a locked technology. It isn't that it's not nice. It's cool, and there are reasons to use some of it. Yes, absolutely, but not your application. The application and its Linux environment, it needs to be agnostic. So to make that happen and to help me stay agnostic and not get trapped in by the cloud provider services that I'm working with, I make sure that I'm using a separate entity resource for the compute power versus the storage capacity. So by doing that, I can do another very critical, important thing. I can go anywhere I want. Get it? See how it works? So if you don't rely on the cloud provider's highly specialized, very localized, and very uniquely functional services like Amazon Linux, or Azure's resource tools, or Google's backups, internal systems, and so on and so on and so on, and you're actually running your own agnostic model. And it's important, because if you don't do that, then you find these really significant snags that prevent you from continuing to maintain your operations. Being agnostic is important when it comes to the core function. Now, I'm all about using cloud services, don't get me wrong. And there are purposes to do that, to maybe increase the performance of your application while it's hosted on their services. Specifically, such as OpenSearch, as an example of one variation of Elasticsearch, and other services that are out there. But the core components, such as the Unix operating system, the open source standard application code for your actual product or your production environment, your backup capacity, in other words, your ability to recover from an image, those core features and functions all need to be agnostic from the cloud provider. And with that being said, I will give you this other piece of advice when dealing with cloud providers, because I've worked on both sides of that fence. I've been behind and building cloud providers and their disk storage and helping them grow into this monolithically constructed cloud service. Yeah, it is actually a monolith, by the way, just in a different kind of way. And I've been on the other side where I need those resources, and I'm going to have to pay for those resources, and it's a little painful, so let's work something out here, because I can't use you if I don't got you, if it's not available for me to use. So with that being said, you have to understand the nature of what's critical for you specifically as a user of the cloud services, and what's optimal and realistic and protective for yourself. This leads to the last critical thing that's very, very critical in the nature of things, and a serious mistake that a lot of companies have made, unfortunately. And that is, you need to have a copy of all of your IP. What is IP? Well, IP is all that code sitting up on those application units that your people coded and wrote and built and have enhanced and changed and optimized and pivoted and shifted and upgraded and so on, so on and so on and so on. You see, if you don't read the fine print on companies like AWS or Azure and Google, there is a very small little clause in their write-up, at least the last time I checked, which was only about 2 years ago, that they can lose up to 3% of your data and not be held accountable and not be charged for the loss of the data. And I'm thinking, you have got to be kidding me. You have any idea what 3% represents in a 12 terabyte database? That's just one of my sources. What a gaping hole to have such a situation like that. Now, I come from the old world of data centers, so we would use something called an EMC RPA, or something similar to a recovery point appliance. And we would go out there and we would connect to those IP sources, and we would replicate asynchronously, about a 6-hour window, the data to a local repository that which we can go to and pull from, and if we have to, recover from a potentially catastrophic event. It does happen. And I have engaged both Google, Azure, and AWS, as my representative will attest, as I've talked to him several times on it, is I don't mind the idea of having an appliance from your provider, as long as your appliance that comes from like Google or Azure or AWS is agnostic of your services. And they're like, oh, no, it's all integrated into our services. And that's a nice little hook, by the way. If they can get into your internal IP storage repositories, they have access to your data. And that's, no, not doing it. Anyways, the point is, using synchronous replication to make copies of your data, may it be in GitHub and your repositories and your instances and your containerization, everything you have, you should be taking the time to make a copy of it, to go to just a simple, let's say 1 gigabit backdoor sublab in your headquarters or somewhere, where all they're doing is accruing backups of that data, and they rotate them out within let's say a 2-year or 24-month period. And that's pretty healthy. You could even go as far as having a tape drive in there and transporting the tape drive to Iron Mountain if you really wanted to. Some companies may require that you do that as you elevate from one corporate level of service to another. In other words, you are a small company, you're now mid, now you want to be a large company based handling service provider. You now have to do something like Iron Mountain. Be prepared for that, because that's part of the growth model that comes out of the equation. Been there, done that. Not fun. So, with that being said, I just wanted to show you an idea of how you can represent 3 different cloud providers in your home environment. And I'm not going to tell you my secret sauce, because that's how I got to learn. It's not difficult. There are many open source cloud provider services you can install on Raspberry Pi. It's not about having a super powerful instance or super powerful capability. It's more of that basically having the core function, and a Raspberry Pi is just fine for that. Or you could look at Aurora or some other little microboards if you want, but I have them, so I used them, right? And they only cost me like $15, so that's what I'm doing here. Now, the last thing is I want to point out to those who have small home labs or not sure exactly where they want to go, and this is probably one of the best and the most effective ways to build a home lab, is based on going to a cloud provider, using containerization, using GitHub, Terraform, and other tools like Puppet or Ansible and so on. This is the cheapest way to do it, in my opinion, because, like I said, let me give you the equation on the math on that part of it. So as you can tell, if I just have 1 or 2 nodes per each region, I'm only burning I'm burning a terribly little bit of power to run these 2 little guys. But I would start with 1 first. And to run this is a standard 12 volt bridge over set, so it's no more than just about, I'd say, 100 watts max ever. And then up here, these are supplied by 90 watt power supplies, which are located in the back. They're very small. They're basically like laptops. Here's one right here, as you can see. And its interface is very simple. It's just power and connectivity, and that's it. Now you can get really adaptive and have some fun with this by using the wireless services to create maybe a management console, but understand that wireless is not a secure network and you are doing stuff at your own risk when you do it that way. So with that being the case, I just wanted to give you guys kind of that bird's eye view of this so that you saw that. And you know, right now you look at this math, this does not get hot. This stays really cool. You just need a fairly good sized room. You have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A 12U, and I would go a little larger. I'd probably go for like a 14 or an 18U. So that you, if you look right here, these are your increments of your rack. So you can have a rack half this size, or even slightly smaller than half. And this would allow you to be able to have your network switches in. You need 2 network switches, a really good one like a 10 gig like this one, and then a 1 gig, and then maybe a deferred one also, if you want to do the, you know, the latency effect, which is valued by the way. It's a very value added. If you had one of your clusters, one of your Raspberry Pi service clusters, act like it's in Australia or something like that, it needs to be a little slower, and it will give you a realistic model of how the data will sync between the pools of disks and create that kind of effect that which you'd be looking for. So with that being said, and this is probably one of my last of my couple of videos I'm making for 2024, I wanted to show you what you can do, and I did all of that for just a few $100. Seriously. You'd be amazed if you get a box on eBay. Yeah, what you do is you get yourself like a small pallet, like 7040s. They'll do it. They'll literally have a box of those and assorted parts, and you might have a couple of dead ones. That's okay. It's spare parts. You know, get a box of them if you can, and pick them up. And or if they come what's called preloads at $50, $60 an increment, they'll have like Windows 11 on them or something like that, and they'll probably have a small little NVMe drive in it that's about 180 or 200 gigs. Fine, that's perfect. You know, why not? Go for it. I say, you know, absolutely go for it, because it gives you everything you need. And you know, the Raspberry Pis, you can get the Raspberry 4s, you can get the Raspberry 5s. Raspberry 4s are fine, you know, and they're getting kind of cheap. I did invest some money into, you know, making it rack mountable, but you don't have to have it, to be honest with you. And of course, any USB disk array, which will run you about, I'd say those ran about $60 each, empty. And then, you know, I bought drives on bulk on eBay, but that cost is nothing, and that lets you put all your money in your network switches, which is where you really do want to focus. And you know, it gives you all the prerequisites you want. You can do containerization, you can do Docker, you can do GitHub, you can do bit configurations. You know, you cannot do ChatGPT. You can't do that. Don't do that. Don't try to do AI. Not on this. This is not that design. You need a whole different piece of hardware for that. But you can do quite a bit with this. Plus, it's going to give you some scaling skill sets, which is important because it helps you understand how cloud providers do it under the hood. So, with that being said, this is Brad Dyke. I'm going to sign off. God bless. I hope you guys stay safe, and you guys take care. Bye-bye.